Perimeter. What is the perimeter of something? If they ask you to run a perimeter in gym class, where do you run? Hopefully along the outside, right? The perimeter is just the distance around the outside of a figure. So let's write that. It's the distance around the outside of a figure. Now, there's tons of different figures, right? Many different figures. You could try to memorize all the different formulas, or you can just figure out how to make up the formula based on the shape. And that's what we're going to do. That's the easiest. So for the formula, the rule is you're going to group together. So group together sides with the same lengths. And then you're going to build your formula off of how many sides you can kind of match up. Okay, before we even get to that, since we're in kind of a new unit, geometry here, pretty much every problem needs 4 different things. So let's write that. Every problem needs. Actually, maybe every answer needs. That's better. Every answer needs 4 different things. First, you need a formula. Then you need to show the substitution line. I know we've talked about this, but the substitution line, you're just subbing the numbers in for the letters in your formula. Like, again, if you were playing a game in gym class, subs are in, numbers, you're in for the letters. That's what you're doing. Okay? So formula, substitution line, you might have to show some work. So show work or show that you're using PEMDAS. And then you need an answer, obviously. And you need units. So really, you always need a formula, substitution, answer with units. Formula, substitution, answer with units. Formula, substitution, answer with units. Okay, you get it. So let's try one. So if I asked you, let's draw a picture here of a rectangle. And let's say the rectangle was 8 inches by 3 inches. And I asked you for the perimeter. So you need a formula, capital P for perimeter. Now I usually use A's and B's. You could use length and width, whatever you want to do. But I'm noticing that here's a side 8. It's going to match with the side across, right? So there's 2 that length. So I'm going to say 2A plus 2 a different length, right? These 2. So really there's 2 8s and there's 2 3s. That's how I'm going to group it together. And then I show PEMDAS, so 2 times 8 is 16, 2 times 3 is 6, going to add those together. I'm at 22. What are my units? I really just measured all the way around. So that's 22 inches. Okay, let's try a triangle here. Number 2, if I draw this, first of all, that is a right triangle because it has a right angle, and I'm going to make it isosceles. Do you know what it means to be isosceles? It means 2 equal sides. And they're going to indicate that by these hash marks. Actually, I could have done it on the rectangle. This could have matched with this. Then if there's another side, they might use double for the other ones to show that they match. Okay, so that does show up on your homework. Watch out for those. So you can kind of count up the matching sides. Now, what would the formula be for this? Well, I'm seeing that there's 2 sides that are, and sometimes I label the picture, 2 sides that are the same and then a different side. So 2 A's plus, you could put 1 B or just put B. That would be fine. All right, just make sure you sub the numbers in the right spots because there's two 25s, right? So the 25's got to go there. The 30's got to be here by itself. So 2 times 25 is 50, plus the 30, I guess this is 80 feet all the way around. All right, good. All right, now let's try an irregular figure. So it's going to look kind of different. So see if you can draw this. A side here, kind of like a castle. This is different than what I wanted, but that's okay. All right, so let's say we've got, this is 4 meters. We'll call this 5 meters, and that's going to match over here. Let's say this is 3 meters. This is, I don't know, 8 meters. And this guy is 6 meters, and it matches with that one. So let's say that was the picture that you got. Ooh, you know what's interesting? I didn't label the bottom side. I did it on purpose. You have to figure out the bottom side before you write your formula. And don't guess. There's a reason it is. Don't go, it looks like it could be about 10. Can't guess. Oh, now I put a smudge. So you have to look around the picture. Here's 3, so you know to here is 3. Then there's 4, so we're up to 7, plus another 8. So this has to be 15 meters based on what's kind of up here above. Okay? All right, so what's the perimeter going to be? And I like to label the picture, otherwise I lose track. So let's say the 4 is A, 5 is B, C, D, E, F. So there's 1A, right? There's 2 sides that are 5. So 2B. There's only this one little C. 1D. 2 of them are 6, right? These 2. So we can say 2E and then F. Ooh, that's long. All right, so there's a 4 plus 2 5s plus a 3 plus an 8 plus 2 6s and plus a 15. All right, so that's 4, 10, that's 11, 12, 15. 4, 14, 25, 37, and 15. That's 42, 52. You better check me on that. Better type that in your calculator. I'll do the same right now. Let's see. Calculator, 4 plus 10 plus 11 plus 12 plus 15. Nice, 52 meters. Okay. And then obviously if I gave you like, I don't know, a scalene triangle, meaning all 3 sides were different. So 3 centimeters, 4 centimeters, and 5 centimeters. Formula for that one, there's nothing you can really, put together. You would have to say just A plus B plus C, that's all. So 3 plus 4 plus 5, looking like 12. Okay. Before we move on, there are some names that you should know. So regular polygons. Regular means all the sides and all the angles are the same. So all sides and all angles are equal to each other. The angles are equal to each other, sides are equal to each other. So what's the smallest shape that has all the sides equal to each other? How many sides? Can a shape have 2 sides? No. No such thing. So the smallest one is a triangle with all 3 sides the same. We'll say that's 3 sides, and that's called an equilateral. triangle. What would be next? 4 sides. You can draw it here. Square. Oh, you know what? Let's just write, if you had to make a perimeter formula for something with 3 sides that were all equal, you could, a lot of times they do 3s for sides. Square, 4s. Pentagon. Do you know what a pentagon looks like? Kind of like a house. All the sides are supposed to be equal. 6. Hexagon. We don't have to try to draw them. 7. Heptagon. 8. You know that one. That's the stop sign. You can try to draw that. Almost. Well, pretend those were all equal. See, that's why the hash mark is convenient. Okay, so there's a few of them. Why did I show you this? Well, what if I gave you a problem? This will be our last one here. And I said to you, let's say it was a pentagon. And I told you the sides were equal. And I told you the perimeter was 40 inches. Could you figure out how long each side was? I bet you can, but can you do it with, remember I said every answer needs a formula, a substitution, an answer with units. So let's try it. What would the formula for a pentagon be? Oh, we wrote it. Oh, we didn't write it. It would be 5s. Now, where would you put that 40? 40 is supposed to be the perimeter, right? So that would go here. Bring down the 5. I would probably sub in this x to show that's what I'm looking for. There. Now, to get x by itself here, divide by the 5. That's the answer I'm sure you were shouting out. But that shows the process, and you would get full credit for having the formula, substitution, answer with units. All right, so make sure on your homework you have those things. Formula, substitution, answer with units.